Let's see how you perform a hypothesis test for two population proportions. Let's go ahead and test the claim that the percentage of left-handed female students is different than the percentage of left-handed male students. We're going to use a 0.05 significance level. So suppose that I went to my class data and I came up with the information that the number of females from my sample is 80, and the number of females who answered left-handed was 7 out of those 80. So the sample proportion, so using our class data as a sample, the sample proportion is x1 over n1, so that's going to be 7 over 80. And we'll go ahead and do the same thing for the males. So let's say we collected a sample of 60 males, and we found that 6 of them said they were left-handed. So the sample proportion of left-handed males is going to be x2 over n2. So that's 6 over 60, which is 0.1. And 7 over 80 is 0.0875. So we can see based off of these relatively large samples that these two proportions are not that far off. 0.08 isn't too far from 0.1, right? This is almost 9% and this is 10%. So based off of this sample, do we really have enough evidence to suggest that the proportion of males and females is different, that they're not equal to each other? Maybe there's more left-handed females or more left-handed males. Do we have enough evidence to support this claim? So let's go ahead and write down what our hypotheses are. So the claim that we notice here in the problem is that we're looking at population 1, the females, versus population 2, the males. And we're saying that the percentage of left-handers is somehow different. So when we see the word different there, so we're testing the difference in the proportions. And so that means that our alternative hypothesis is going to say that P1 does not equal P2. Or in other words, the proportion of female left-handed students, I'll color code this here in blue. So the proportion of female left-handed students is different than, is not equal to, the proportion of male left-handed students. And so that becomes our alternative hypothesis. So I'm going to go ahead and put my arrow next to that hypothesis because that is my claim. And our null hypothesis must contain equality and contradict the alternative hypothesis. So that's going to say that the proportion of female left-handed students is equal to the proportion of male left-handed students. Let's go ahead and write each of those claims in some, not just in symbolic form, but in words as well. So now that we have our two hypotheses, we're going to want to go ahead and take our sample data and figure out what our test statistic is. So since we're testing a proportion, well, the difference between two proportions, we're using the normal distribution. So our test statistic is going to be a z-score. Now, the formula that we use in order to calculate a test statistic by hand when we have two populations that we're comparing is we first go ahead and take the difference of the sample proportions, so P1 hat minus P2 hat, and then you subtract the difference in the claimed population proportions. Well, the claim here, remember the null hypothesis is assumed true until proven otherwise, right? The claim is that P1 equals P2. So if you think about that claim as a subtraction problem, P1 minus P2 is equal to 0. So this piece right here is almost always 0 in these problems, unless otherwise indicated. And then we go ahead and divide by this expression, the square root of P times 1 minus P times 1 over N1 plus 1 over N2. So let's go through all the pieces necessary in order to calculate Z. So first of all, you need P1 hat, which is our population 1's sample proportion. So that's 0.0875. And you need P2 hat, so that's our second proportion's sample proportion. And then we know that the difference in the population proportions are going to be 0. So we have this number, and then we know this is 0. And then we need to divide by the square root of this, p times 1 minus p. Well, what is just regular p without a subscript? How can we refer to a p when we have two populations? So regular p is known as the pooled proportion. And it's basically the proportion that we get when we add our two samples together. So our pooled proportion P is x1 plus x2 divided by n1 plus n2. And again, we have all of those pieces, right? x1 is 7, x2 is 6, so we'd have 13 divided by the sum of 80 and 60. So it'd be 13 over 140. So that's what we plugged in here. That's what we would plug in here. And then you have 1 minus that number, times 1 over the sample size for population 1 plus 1 over the sample size for population 2. So we could plug all those numbers in and calculate this on a calculator, but StatDisk is going to do this for us. And what we get when we use StatDisk is negative 0.2522. So I'll just take it to 2 decimal places, negative 0.25. So that's our test stat. And so if we think about the picture here, negative 0.25 is not too far down there in the negative land, about there, right? That's our test stat. And if you look at the alternative hypothesis, we have a not equal to. So this is going to be a two-tailed test. So our p-value is going to be everything to the left of negative 0.25 and everything to the right of positive 0.25. So everything I colored in there is my p-value. Again, StatDisk is going to calculate that for us. So let's go ahead and see what that is in StatDisk. So our p-value comes out to be 0.8009. So now we're ready for our conclusion. So what are we going to conclude here based on that p-value when we compare it to our significance level of 0.05? Well, since 0.8009 is greater than our significance level, we are going to fail to reject the null hypothesis. By failing to reject the null hypothesis, what does that mean in the context of our claim? I've failed to reject the statement that P1 equals P2. So if I haven't rejected this statement, then that means I cannot support the alternative hypothesis, which is that the two proportions are different, and that was my claim. So in other words, I'm not supporting my claim. So we are concluding that there is insufficient evidence to support this claim that the proportion of female left-handed students is different than the proportion of male left-handed students. So the more easy conclusion to digest here is that it is likely that the percentage of left-handed students is the same for both genders. So here's how you do it on StatDisk. You're going to go to Analysis, Hypothesis Testing, and Proportion to Samples. And so first you'll want to make sure that you change your alternative hypothesis to match. And so in this case, we used the first option, which is the population 1 is not equal to population 2. And then my first sample was of size 80 with 7 successes, and my second sample was of size 60 with 6 successes. So this information represents the females, and this information represents the males. Now, there are some requirements that must be met in order to perform this hypothesis test. And one of them, probably the most important one that you'll be faced with, is that the number of successes in each of these has to be at least 5 in order for this to work. And actually the number of failures does too. So this number here can't be too close to 80 and it can't be less than 5. And this number here can't be too close to 60 and it has to be less than or more than 5. So make sure if you get an error, it's probably because of these numbers are not big enough or maybe they're too big. But when I go ahead and evaluate this information, you can see here's my test statistic of negative 0.25, and then here's my p-value of 0.8009. We also notice the confidence interval here. So this is a 95% confidence interval, and we could have constructed this interval by going to analysis, confidence interval construction, and then proportion to samples. But hypothesis tests also produce these intervals for us. Because this is a two-tailed test, they're splitting this 5% in both tails, so that's why we get this 95% confidence interval. If we had a one-tailed test, this would actually be a 90% confidence interval. So let's talk about the interpretation, though, for this confidence interval. We're talking about the difference between P1 and P2, the proportion of female left-handed students and the proportion of male left-handed students. And we're saying that that difference between those two percentages is between negative 11% and positive about 9%. So what conclusions can we make based off of this information? So our interval tells us that the difference in these two population proportions of, the proportion of left-handed students, females P1, males P2, is between about 8.5% on the high end and negative 11.05% on the low end. So we can come to the generic conclusion. We are 95% confident that the difference between the population proportion of female left-handed students and male left-handed students is between negative 11% and positive 8.55%. But some other information that we can gather here is that since 0 is in the interval, it is possible that the two population proportions are equal, right? 0 is pretty squarely between negative 11 and 8.55. That is, the proportion of female left-handed students is equal to the proportion of male left-handed students, right? Because if 0 is in between there, that means that P1 minus P2 could be 0, which means that P1 equals P2. And the final conclusion we can make is to realize that, again, even though 0 is pretty close to the middle of that interval, the interval technically does contain more negative numbers, about 3 negative percentage points more than the positive side of the interval. So that means that the difference between P1 and P2 is less than 0, right? That's what it means to be negative. And so that means that P1 is probably less than P2. In other words, the proportion of female left-handers is possibly less than the proportion of male left-handers. I don't think the evidence for that is incredibly strong. I think that because 0 is so close to the center, the evidence really suggests that they are equal to each other. And that was the conclusion that we came to in our hypothesis test. So a little bit of a recap. In order to do a hypothesis test for two population proportions, you need samples from two independent populations. So these independent samples have sample sizes of N1 and N2 respectively. You'll also need to calculate the number of successes in each sample. So that notation would be X1 and X2 respectively, right? So X1 would have been the number of left-handed females and X2 would have been the number of left-handed males. And then you can calculate your sample proportion. So that's going to be P1 hat, which is X1 over N1. And the sample proportion from population 2 would be P2 hat, which is X2 over N2. Then you'll want to go ahead and state your hypotheses. Now remember, we have 3 types of tests. So if your alternative hypothesis is a not equal to symbol, then you have your two-tailed test, and your null hypothesis has an equal symbol. If your alternative hypothesis is a less than symbol, then it's a left-tailed test. And if your alternative hypothesis is a greater than symbol, then it's a right-tailed test. Now, each of these hypotheses can be written using the difference notation. So for example, P1 equals P2 could be written P1 minus P2 equals 0. And that would be sufficient. But I think having the different proportions on either side of the symbol is more intuitive in our brains than to think about the difference. But it really is the difference is what we're using in order to calculate these probabilities. And you can really see that in the test statistic. The formula for finding the test statistic is quite a bit of work, and so we will primarily rely on technology to do this for us. But again, you can see that it relies on the difference of taking those sample proportions, and also what we're trying to estimate is the difference in the population proportions. So that's how it's used in the calculations. And then remember, the regular p is the pooled proportion, which is the sum of your successes divided by the sum of your sample sizes. Again, the test stat is a z-score, and once we have the test stat, then we can calculate our p-value. And so our p-value, again, depends on what type of test it is. So if it's a two-tailed test, the p-value is these two tails. If it's a left test, then it's just this left tail. And if it's a right test, then it's the right tail for whatever that test statistic is. Our conclusion is the same. If we have a p-value that's less than the significance level, we're going to reject the null hypothesis. And if it's greater than the significance level, we're going to fail to reject the null hypothesis. So once you make your conclusion, you're going to want to then interpret your conclusion in the context of a claim. And that really takes you back to the hypotheses. Was the null or was it the alternative that was your claim? And are you supporting or are you not able to support that claim based on your conclusion?